All right, welcome. Today we are digging deep, and I mean that literally. We're talking about soil, and I'm going to tell you right now, by the end of this, you will never look at the ground the same way again. We are about to unearth some incredible secrets.
You know, we walk on it every day, but soil is so much more than just the ground. It's this complex, living, breathing ecosystem. It's the foundation of our food system, it's a massive water filter, and it literally holds entire ecosystems together. It is way more than what we see on the surface. So, that gets us to the big question, right? Is it all just dirt? You know, that simple brown stuff? Well, the answer is a huge, resounding no, and we're about to find out exactly why.
So here's our game plan. First, we'll look at the anatomy of soil, what it's actually made of. Then, we'll see how that makeup creates its key physical properties. After that, we'll figure out how to classify different soils. And finally, we'll tie it all together to see why this stuff really truly matters.
Okay, first up, the anatomy. Before we can understand what soil can do, we have to know what's in it. So let's break it down to its most basic components.
At its most basic level, all soil is really just a mix of three types of mineral particles. And the only thing that separates them is their size. You've got clay, which has the absolute tiniest particles. Then there's silt, which is kinda in the middle. And finally you have sand, with the biggest, coarsest particles. And believe it or not, this simple difference in size controls everything else we're about to talk about.
Now, what's really cool is that these particles, along with all the organic stuff, don't just get jumbled together. Over long periods of time, soil actually organizes itself into these distinct layers, kind of like a layer cake. We call them horizons, and each one has its own unique mix and its own specific job to do.
So let's start right at the very top, with what's called the O horizon. Think of this as the living, breathing skin of the Earth. It's usually a thin layer, but it's packed with organic material, decomposing leaves, pine needles, and all the little critters that break it down. It's the engine of the soil ecosystem.
All right, so now that we know what soil is made of, we can get into the really interesting part, how it behaves. These are its physical properties, and they're what determine if a field can grow crops or if a hillside will wash away in a storm.
Okay, we've got to get these two terms straight: porosity and permeability. They sound alike, but they're very different. Think about a kitchen sponge. Porosity is just how many holes it has, all that empty space. But permeability is how well those holes are connected. It's what allows water to actually flow through the sponge. A soil can have tons of empty space, but if those spaces are dead ends, water isn't going anywhere.
Let's make this real with a quick experiment. Imagine a scientist takes a sample of some soil, and they pour exactly 100 milliliters of water over the top. They're collecting whatever manages to drip out the bottom. What do you think is going to happen?
98 milliliters. Almost all of it. Getting 98 milliliters back is a huge amount. That tells you one thing very clearly. This soil has incredibly high permeability. Water just zips right through it. This is classic sandy soil behavior. The big particles leave big, connected gaps, so water has an easy path straight down.
But that high permeability leads us to another critical idea: water holding capacity. And this is just what it sounds like. It's how well the soil can hang on to water instead of letting it all drain away. And for any plant to survive, the soil has to hold on to at least some of that moisture.
And right here, you can see the fundamental trade-off. Sandy soil, with its high permeability, has a low water holding capacity. The water just rushes on through. Clay soil is the complete opposite. Its teeny tiny particles create tiny little spaces, so it has very low permeability, but a high water holding capacity. In fact, it can hold water so tightly that it gets completely waterlogged.
Okay, so we know we have sand, silt, and clay. But how do we figure out the exact mix in any random handful of soil? Let's look at how we classify it, using both a really simple DIY method and a more precise scientific tool.
You can actually do this yourself. It's called a jar test. You just scoop some soil into a jar, add water, shake it up, and let it settle. The particles will separate themselves out by size. The heaviest stuff, the sand, drops to the bottom first. Next comes the medium-sized silt, and finally, the finest, lightest clay particles will settle in a layer on top. You can see here in sample B, we've got very clear layers of all three.
Now, for real precision, scientists use this, the soil texture triangle. It looks complicated, I know, but it's really just a map. Let's find our sample B. We measured it and found it's 40% sand, 40% silt, and 20% clay. So we start at the bottom with 40% sand and follow that diagonal line up. Then we find 40% silt on the right side and follow its line down into the left. Finally, we grab the 20% clay line on the left side and follow it straight across. And look at that. They all cross in one spot. That spot tells us our soil type is loam. And loam is what farmers and gardeners dream about. Its balanced mix of sand, silt, and clay gives it the best of all worlds. It drains well, but it also holds on to enough water and nutrients. It's pretty much perfect for growing things.
Okay, this brings us to the big so what question. We've taken soil apart, we've classified it, but why does any of this actually matter in the real world? This is where it all comes together, from your backyard garden to the health of the entire planet.
I mean, really, how does knowing you have 20% clay instead of 30% clay help you make better, smarter decisions about how to manage the land?
Well, it lets us solve very specific real-world problems. Let's say a farmer's field is always a swampy mess. They know they probably have too much clay. The fix? Add organic stuff like compost to improve the soil structure and let it drain better. Or maybe you have soil washing away on a steep hill. Building terraces can slow that water down. Losing nutrients year after year? Rotating crops can help rebuild that soil's health. You see, the knowledge leads directly to a targeted solution. So it all boils down to this really simple but powerful process. First, you test your soil to see what you're working with. Second, based on those results, you figure out what the land actually needs. Better drainage, more nutrients, whatever. And third, you put the right solution in place for that specific problem. And remember, the impact here goes way beyond just farms. Healthy soil is like a giant natural water filter, cleaning the water that seeps down into our aquifers. It provides the literal foundation and stability for our forests, our wetlands, our grasslands, you name it. It's a cornerstone for the balance of the entire Earth system. So, the next time you step outside, just take a second and remember that the ground under your feet isn't just dead dirt. It's a dynamic, living, layered world with an incredible story to tell. What will it tell you?